All right, let's do just a really quick how to describe data. All right, so for qualitative data, we have to define our categories such that each observation or each element collected, data point collected, falls into only one of those categories. And then we can go ahead and numerically describe those via the number of observations or the proportion of those observations. And it's usually in either a bar chart or a pie chart, as seen below. Now, there is something kind of interesting that you can do. You can organize your bar chart from highest frequency to lowest frequency, and then you can superimpose a cumulative distribution line, which is what we call the Pareto line, and having the bar chart with the line it's a Pareto diagram. So a way to do that in Excel is to start with our first bar chart, and then you can add data via the select data, and you can change that chart to a combo chart, and the new data or the cumulative data that you're going to use would be in a line format. So essentially you're creating a second column, and that would be the accumulation or the summation as you go down through all these different categories of all of your data, such that the last data category would end up at the 100% mark. So in Excel, pretty easily done in the chart element, but it is an interesting way to show your data. And obviously with quantitative data, the histogram is the best way to go. All it is a display of frequencies. What I've got here is the normal distribution superimposed on the histogram. Very easy to do with SPSS, a little bit more cumbersome in Excel, but you'll be using SPSS to go ahead and create that histogram. In terms of where should our data points fall within those distributions, if we're looking at a normal distribution, we should probably have 68 of those data points within one standard deviation, 95% within two, and then almost all of the data points should be within 3 standard deviations. Another nice way to go ahead and look at how to describe our data is using percentiles. Lower quartile is the 25th percent, the 50th percent, and then the upper quartile is the 75th percent. So you can use those to describe your data. You can also use a z-score, and the z-score is a really nice way to convert your data points to a standard z-value, and that would be able to tell you if you had a normal distribution where your mean was 0, if you had a value of 1.2, we have really nice distributions, 1 standard deviation away from the mean, 2 standard deviations, and 3 standard deviations. So if you had 1.2, your value is falling somewhere here. So now you know how that falls within that normal distribution. Now in order to find the quartiles, you're going to rank your measurements in increasing order. So let's say we've got four data points. Let's do 6 data points, 7 data points to make it fun. So we have 7 data points. So our L value would be 7 plus 1, or 8, times 0.25. So that says 2. So that is referring to the order number. So that would say our Q sub L, which is our 25th percentile value, is 2.6. And our Q sub U value, 8 times 0.75 is 6. So 9.1 is our Q sub U value, or our 75th percentile. Now we have an odd number, so we just need to find the middle of this data set, and the middle happens to be 7.2, so that is our 50th percentile value. All right, outliers. Why do we have outliers and how do they get there? Well, sometimes we just are not, the sample doesn't really represent our population, so that could be an issue. We've also got that 95% issue, so we're expecting 5% really not to necessarily fall where we expect. There's two real methods to find out whether or not an individual data point is an outlier, and that's via the z-score or the box plot. So for the box plot, anything that falls between the inner and the outer fence could be considered an issue. Anything that's outside of that outer fence is highly suspected of being an outlier. And then the z-scores, again, between 2 and 3, the suspect, anything greater than 3 is definitely an outlier. When we talk about a box plot, we generally start with the x and the y axis, with the x-axis not having really any information on there. However, the y-axis has from 0 to whatever our largest data point was. And then in that diagram, you'll have a little rectangular box, and the top of that rectangular box will correspond to our upper quartile, and then the bottom corresponds to our lower quartile. We'll usually have a solid line in the middle of that rectangular box, and that is our median value. And then a little plus sign in the middle is our mean value. And then we'll have sometimes they call them whiskers and fences. So we have an upper inner fence and an upper outer fence. And usually that is connected with just a bunch of dots. And then we have a lower inner fence and a lower outer fence. All right, so our fences are determined based upon a couple of very easy equations. So our lower fences, and we have our inner and our outer, Q sub L minus 1.5 times our inner quartile range, and then our outer fence is Q sub L minus 3 times our inner quartile range, and then our upper fences, Q sub U plus 1.5 times the inner quartile range, and Q sub U plus 3 times our inner quartile range. And our inner quartile range is pretty easy. It is just the Q sub U minus our Q sub L. So that's how you would go through and construct a box plot. SPSS does that for you, so you don't have to go through all the various combinations of how to do this, but at least that gives you information on how to do that should you want